Hi, I'm Christina Broomfield. I'm a teacher in North Kingstown, Rhode Island, and I also work with education and engineering researchers here at the University of Rhode Island. I heard you've been studying how changing climate systems impact our communities. What have you learned about these changing systems and their impacts? Hello.
Hello.
Hi. So this is the Water for the World lab, right?
Yes, this is the Water for the World lab, and I'm Dr. Vinkoya Nadel-Craver, and I'm a professor at Civil and Environmental Engineering and one of the directors of the Water for the World lab. In this lab, what we try to do is to understand the sources of pollution in our cities and towns, and also to find solutions for this problem. And Andrew is one of the researchers here.
Hi, I'm Andrew Sheeran. I am a researcher in systems and environmental engineering here at URI. And for this lab, the research topic I'm focused on is stormwater pollution.
That's interesting, Andrew. One of the things I've noticed living here in Rhode Island is that we've got a lot of traffic on our major roads. I'm wondering how heavy traffic might impact our environment. What problems do you think heavy traffic on our roads might cause for our environment? Let's check in with Andrew and see what he thinks about this question.
Let's talk about why stormwater pollution is a problem in Rhode Island. We all know that Rhode Island is the smallest state, and it also has a lot of people that live really close together, making it the second densest state by population. That comes with a lot of cars and traffic on our roadways. Cars pose a significant source of pollution because the tires, the brakes, or the exhaust can release pollutants that can accumulate on our roads over time. This poses a problem for our environment, especially when it rains.
What do you think happens to the pollutants on the road when it rains? How might this cause problems for our waterways? Community members are concerned that if these pollutants get into our water, it could make our drinking water unsafe or harm the organisms that depend on our waterways to survive. So city planners have developed a system using storm drains and collection pools to deal with the problem of stormwater runoff. When it rains, storm water flows down storm drains and is then carried directly to the nearest stream, river, or bay. Collection pools are also helpful because they collect stormwater and allow sediment and pollutants to settle out of the water before it is released back into our local waterways. Over time, due to climate change, we've experienced changes in the patterns of rainfall that we experience here in Rhode Island. What changes do you notice in the data? Hey Andrew, what have you noticed?
So climate change has changed weather patterns around the world, and it's showing in recent decades. We're creating a warmer environment, which is adding more water into the atmosphere, and this is creating the right conditions for extreme rain events. As you can see by the data, we haven't seen a drastic change in the amount of rain that we've gotten over the recent decades. We're only really seeing about a 10% growth, or about 1 inch of rain per decade. However, when we take a look at the extreme rainfall events, which is defined by a rain event of greater than 2 inches, we do see a pretty significant trend in the recent decades. You'll see that in this graph. In the 1950s, there are not that many extreme rainfall events, between 1 and 2 a year. However, in the recent decades, we're seeing 3 or 4 extreme rain events each year. This is a problem from a stormwater management perspective because we're seeing more flooding and therefore more stormwater runoff pollution.
It doesn't seem realistic to rebuild the entire system of storm drains, collection pools, and pipes throughout our state. What do you think might be some other solutions to prevent these pollutants from getting into our waterways? This is the problem Andrew and his team have been trying to solve.
Since Rhode Island is so dense, it is already built up. And because of that, there is a lack of space, plus it is expensive to construct some of these stormwater management systems. So we need to look into other ways to reduce the amount of pollution washing off into our water bodies during rain events. And one of these ways is by cleaning our streets using street sweepers.
So we're working with the Department of Transportation to improve the ways that they are cleaning the roads. Our project is helping them to find alternatives that they are not going to be only economical, but also they are going to be reducing a lot of the pollutants that end up in Narragansett Bay.
As environmental engineers, we aim to find a solution for this problem. We are running an experiment in which we try to understand what type of pollutants there are, how much of those pollutants there are, and the trends on where these pollutants are accumulating. We're going to use this data to prioritize which roads to sweep and how frequently to sweep them in the most efficient way possible.
So let's see how we did it.
Based on what we found from other researchers' work, we found that land usage, tree coverage, and impervious surfaces are the three major factors contributing to stormwater pollution. We can look at this data using GIS. GIS stands for Geographic Information Systems, and it's helpful for us to visualize these spatial data sets geographically on maps. GIS is a powerful software that allows us to make models and make calculations on these spatial data sets. Let's take a look at our factors. So we'll first take a look at land usage throughout all of Rhode Island. On the legend on the left, we see a color coding for each land use category. Land usage can be broken into three classes: commercial, industrial, and residential areas. Let's turn that on. And the human activities happening in each of these land uses can alter the amounts and types of pollutants that can accumulate on our roads. We'll see that a lot of the area in Warwick is residential, and there is a good amount of commercial area, but not that much industrial areas. Let's take a look at our tree coverage. Tree coverage is important because they can drop leaves and branches, and this tree litter can contribute to the nutrients and suspended solids in excess in our stormwater pollution. We can see in Warwick there's a lot of low tree area. Lastly, we'll take a look at our impervious surface areas. Let's turn this on. The impervious surfaces are all of our roads, buildings, sidewalks, and parking lots. The areas with high impervious surfaces can accumulate more pollution on their roads and also can contribute to an excess of stormwater runoff. For this project, we worked with the Rhode Island Department of Transportation to identify 8 sites throughout the city of Warwick where we would take samples from to find trends in pollutant accumulation. We used GIS to decide these 8 sampling locations based on different land uses. We have 8 segments all around Warwick, varying in residential, commercial, industrial, and tree coverage areas.
Once Andrew and his team vacuum up the street solids, they take them back to the lab for analysis. Let's see what Andrew's up to in the URI Soils Lab.
After we've done our particle size distribution using sieving, we have our largest particles on the left and our smallest particles on the right. We do this to do a more refined analysis of what pollutants are showing up in our street solids. Now that we have our individual bottles, we can understand what pollutants are showing up in which particle size range, which helps us understand what pollutants are showing up on our roads. We use this device called an autosampler. This device allows us to remotely collect stormwater over the course of an entire rain event. We collected some stormwater last week, so now we're going to prepare them for analysis. Now we've moved down to our analytical core, where we perform analysis on different water samples. We're going to look at our ICP-MS, which stands for Inductively Coupled Plasma Mass Spectrometer. We use the ICP-MS to detect our heavy metals, which is a major pollutant of concern for us. The ICP-MS uses a highly precise and accurate analytical technique to detect trace elements at extremely low concentrations, as low as 1 parts per trillion. That's really, really tiny concentrations. Even at low concentrations, some metals might be very toxic to our ecosystem and environment. Now that that's done, let's look at the results. The mass spectrometer gave us this spectra, which shows the intensity of the heavy metals that we're concerned about.
Andrew got some really interesting results from the test sites. What information does the map show us? What do you notice about the factors at the different sites? What patterns do you notice? And what do you wonder?
Based on what we found from our sample analysis and from an overview of other researchers' works, we weighted the factors for land use, tree coverage, and impervious areas to prioritize which roads to street sweep. We also determined that spring, summer, and fall may introduce additional trends in pollutant accumulation, so we created unique weights for each of these seasons. In the end, we use this data in GIS to make a tool which calculates the priority scores for each road in which we will be street sweeping. Here's a map that shows the priority scores for spring. We have our high priority areas color-coded in red, medium, orange, and our low in yellow. We can also turn on our summer prioritization and our fall prioritization. You'll notice that in the fall, we prioritize the high canopy coverage areas, whereas in the spring, we prioritize the commercial areas. This tool will be used by RIDOT to help them make decisions on where and when to street sweep. Using this data, we can help reduce the stormwater pollution washing off from our roadways and help restore the water quality in Narragansett Bay.
Wow! So what do you think? Would your local area be a high or low priority for street sweeping? Perhaps you're interested in designing solutions to problems in your community. Maybe you're interested in working on a project like Andrew's at the Water for the World Lab. If you are, consider a degree or a career in civil, systems, or environmental engineering. And thank you for working with us today at URI. We hope to see you around campus soon.
Bye.